Hello and welcome to part 5 of the Form 4 Maths chapter 1, which is functions. Today we'll be looking at two basic examples that you can find pretty common in this chapter. So according to here, example number 1, we have the question of given that fx equals to 3x plus 5 and gfx equals to 12x minus 7, find g squared x. So the first thing that they want us to find is, oh, this is different. Hold on, here we go. Okay, so I'll be using red right now. So the first thing that they want us to find is g square x, and they only gave us fx and only gfx. With inverse functions, you can find gx. Okay, let me just write over here. It needs to be known that g square x is the same as gx. So in the end, we still need to find the function g. So in order to find function g, we just need to put these two functions into one and just we just need to use inverse functions to just basically put it into these two functions to just find the function of g. So firstly, we need to find the inverse function for f. So let's just say over here that the inverse function of x equals to y. It's kind of like the same as what I taught in the past video, but I'll be doing it like this, and then I'll be subbing x with y, so 3y plus 5 equals to x, and now I need to find y, so y is x minus 5. I move the 3 over, so it's over 3, so hence f negative 1, which is the inverse function for f, will be x minus 5 over 3. No, wait, that's not the final answer. Okay, so now that I found the inverse function for f, now I can find g, the function g. So the gx would basically be gf f negative 1 x, because like this one is 1 and this was negative 1, so they'll cancel each other out, and then you can still find g. So which is gf f negative 1, which is x minus 5 over 3, which is equal to gf x is 12. I sub the x with x minus 5 over 3, so x minus 5 over 3 minus 7. So after doing some quick calculations, it will be 4x minus 20 minus 7, which is 4x minus 27. So now I found gx. So now, according to the first part over here, I'll be undo. According to the first part over here, g squared x is gx. So I already found 1g, so it's actually pretty easy. G squared x equals to gx equals to g, after I know g already, 4x minus 27, which is basically 4. The object has changed to 4x minus 27, so 4x minus 27 minus 27. So it will be 16x. 4 times negative 27 is negative 108, so it will be negative 135. So there will be g squared x, and that's just how you would find the answer to this problem. It's not actually that hard, you just need to know which steps to take before you start doing it. So now that that's done, now example number 2. Okay, the functions f and g are shown below in the graph, like showing it with a graph. There's function f, and through an arrow diagram, which is more common actually, you can see gx. So let's just start off with A. The question A. State the type of relation of fx. Okay, according to this graph, in order to do this, you need to understand this graph first. I think I already mentioned it in the first video, that the bottom, usually the x-axis is the object, and then the y-axis is the image. Usually, most of the case anyway. So you can see over here that negative 1 has one image, negative 2 has one image, negative 3 has one image, and negative 3 has one image and negative 3 has one image. But 9, the image 9 has two objects. So there are only 4 types of functions, in which is like one to many, many to one, many to many, or one to one. And according to this, there's no way it's one to many, because none of these objects have more than one image. They all only have like either none or only one image. And the solution to this will be, you look at, okay, image 4 has only one object, so that's normal. Image 1 only has -1, that's normal. Image 5 has no object, so that's fine. So we can just ignore that. But image 9 has two objects. So if there are multiple objects connected to the same image, it would mean that it will be a many to one relation. Because many to one relation means that multiple objects are connected to the same image, in which over here 3 and -3 are connected to the same image, which is 9. So that would be the answer to A. So answer to B will be, okay, let's just take a look at B first. State the function notation for gx. As what I stated earlier in the past video, the function notation is basically an equation showing what the function does to the object in the first place. Let's say that, like this, let's just say for example, function x equals to x plus 1. So if the object is 3, the function of x through 3 will be 3 plus 1, which is 4. So that would be the function notation. So now to do this, now we just need to write out over here, okay, the g of -7 would make us 8. As for -2, if the object is true, it will turn into 3. And then if the object is 3, it will turn into -1. Okay, how do I explain this? You just need to find like what are the similarities that can connect this in the first place. Like all three of these have a certain similarity. Now how do I explain this? Okay, you notice that over here that the negative turns into the positive, like the negative object turns to the positive image, and then the positive object turns to negative image. So you can kind of conclude that it will be -x first. Okay, okay, equals to -x. Okay, now that all this is swapped over, so in some way, after this one is like the sign of this, it turns from negative to positive. This is in some way turn to 8. As -2 turns into 2, and this is in some way turn to 3. And oh, I think I missed something over here. I think I wrote the question wrong. Hold on a little while. No. This one should actually be -2. Yeah. Sorry about that. Okay. And then now, as 3 tends to -3 because it's a -x, initially in some way turning to -2. Let me just cancel this out, -2. So the similarities, I bet that you all can see this right now, is +1, +1, and +1. So gx is -x plus 1. Okay, let me just write over here. Gx equals to -x plus 1. So through this equation, all these objects turn into their corresponding images. So now that that's done, now we get into something less about theory, which is, okay, let's just have a look at question C then. Find gf with the object being 4. So with this, we need to find the function f and function g first. Well, luckily, through question B, we already know the function for g, but now we need to know what is function f. Okay, pretty sure that you all can see this by now. -1 turns into 1, 2 turns into 4, and 3 and -3 both turn into 9. And what do they all have in common? They are all squared. Now the objects are all squared to turn into whatever the images are. So, okay, let me just write over here, fx equals to x squared. And let me just write the extra one, like just to keep it all on the same question, equals to negative x plus 1. Okay, now I need to find GF4. GF4. Okay, well, we can just put F4 in there first. Okay, when I put in, okay, I already told in a past video that you can just sub the image, like sub x with 4. So let's just do that. So it'd be 4 squared, which is basically G16. So with x, with the object being 16, I just need to sub it in. Okay, oh god. Equals to negative 16, because x is changing to 16 plus 1, which is negative 15. And that's GF4. Now that that's done, let's go into the final question, D. Find hx if fhx equals to 8x minus 5. So, let's just get it all there first. Fhx is equal to 8x minus 5. Fhx equals to 8x minus 5. Did I write it correctly? Yes. And f is x squared. And f is x squared. So what do they want us to find? Hx. So we can just use the inverse function again to find hx. So let's just find the inverse function for f first. Let the inverse function for f equals to y, function y equals to x, and then y squared equals to x, y equals to the square root of x. Hence, the inverse function for x will be the square root of x. So now we can just find hx already. Let me just find a space. Let me just use another color. This one may require some moving around. Hold on for a while. The power of digital technologies. Okay, now. So now we already know f negative 1, so it will be hx will be equal to, is kind of the same as f negative 1 times the composite function fhx, because negative 1 and 1 combined together, it becomes f0, f to the power 0, which is 1, which is still the same. So now, f negative 1, okay, the fhx is 8x minus 5. And what is f negative 1? The square root of x, and with the x changing to 8x minus 5, so it will be the square root of 8x minus 5. And that's hx. And that seems to be everything solved for this part as well. So that's two basic examples done. So that's all for today. And in the next video, I'll be talking about, well, as you can see at the right over here, we have example 3 and example 4. Those are actually the harder questions, which are more, they're not 100% like just focus on one part. Oh god, that was a bad way to explain it. But basically, they're just kind of like harder questions and something that just requires a little bit more thinking of them. So thank you all for watching this video, and see you in the next one.